Okay, we are back at lecture part 3 and we're looking at calculations involving suspension and their ingredient and the ingredients that are used. And we are looking particularly at using pure ingredients. So the source of the active pharmaceutical ingredient now is the pure powder. And remember, because it's a suspension, the pure powder, usually the active pharmaceutical ingredient, is going to be insoluble. Just a point to note, even though we have examples here using only one active pharmaceutical ingredient that is insoluble, you can have more than one active pharmaceutical ingredients that are insoluble. Okay, and you can also have excipients that are insoluble, right? So it doesn't have to be just one of the ingredients that's insoluble, it can be more than one. All right. So we have a prescription here. Note the Signatura SIG 10 milligrams per kilogram stat, then 5 milligram per kilogram QID, POPC times 7/7. You were taught already, and I believe you do know that there are certain things you're going to scan for in your prescriptions. You're going to scan the age, the name of the patient. You're also going to scan the date at which the prescription was written, and you're also going to look at whether or not certain parameters such as weight, height, body surface area is written there. In this case, we have the weight and we have the dose recorded as milligram per kilogram. So, we have to do some calculations there. So let's look at the prescription or the instruction, sorry. Calculate the amount of ingredients needed to extemporaneously compound the prescription here, such that 40 milligrams of the drug is contained in 2 mils of the suspension. And the available stocks included are ibuprofen powder, syrup, benzoic acid, 5% stock solution, and purified water. Now, just looking at the ingredients, we have identified that there are no suspending agents. We have a syrup in there, which is typically what you're going to encounter when you go in practice. So the syrup is going to act as the viscosity enhancing agent. So sometimes we tend to use as much as 20 or 30% if we don't have a suspending agent, just to confer some amount of viscosity to the suspension for reasons we had discussed before, because we want to retard sedimentation rate, etc. Just to let you know that generally speaking, when you get a prescription like that, they will not tell you what the concentration is. And the concentration was given in this instruction. Can you identify it? If you have identified 40 milligrams in every 2 mils of the suspension, you would have been correct. That is given because it's a question that you're going to be assessed for. However, in practice, the doctor is not going to tell you how many mils the dose must be in. You're going to have to figure that out. And you figure that out based on, one, the age of the patient. So if it's a small child, like a 2-year-old, or if it's an infant, a neonate, child just born, you're not going to give 1 teaspoon for a child that is just born. You will put the dose in, say, 1 mil. Okay, so these are some of the parameters or some of the issues you're going to have to work through as a compounder when you are determining the concentration. But for the purposes of assessment in your course, we will give you the concentration. All right, so let's get to it. The first thing that we ought to do is to interpret the Signatura. And it says here that for each kilogram, the person is to get 10 milligrams as a start dose, and then 5 milligrams for each kilogram for the second part of the dosing regimen. And that is given for over 7 days. So in calculating the single dose, we have to convert the pounds to kilograms, and that is going to be 113.64 milligrams, which you all know how to work already. Then we're going to calculate the maintenance dose. Now I want us to see the difference between a stat dose and the maintenance dose. So the start dose is what you give immediately, and the start dose is normally different from the maintenance dose. The start dose is what you want to take to get the drug to start working quickly. So you notice the person is getting twice as much of the start dose, twice as much of the maintenance dose as a start dose. So instead of getting 5, they're getting 10. So we want that drug to start working quickly. Ibuprofen, it's an anti-inflammatory, helps with pain and inflammation. So we want the drug to start working at a particular time. And then after that, the maintenance dose, what you're going to maintain that dosing level with, that dosing level is going to be at 5 milligrams, right? And that's what we call the maintenance dose. So you're maintaining that therapeutic level by giving 5 milligrams. So notice it is start, then 5 milligrams. So the start dose you give now immediately to let the drug start working. And because the drug is given 4 times a day, which works out to be every 6 hours, 6 hours from that start dose, you're now going to start giving the maintenance dose. And that is how you're going to instruct the patient. So calculations of the maintenance dose is easy again. It's 5 milligrams per kilogram. We know what the kilogram weight is, and that is 56.8 milligrams. So we're going to determine the total amount of ibuprofen, which is going to be based on the start dose. It's going to be based on the maintenance dose. It's also going to be based on the BUD. Now, recall that BUD is 14 days maximum, but this drug is only given for a maximum amount of time of 7 days. So we're good. We're in the clear. 7 days is fine, right? So we're going to give the therapy for the duration of 7 days. So the total amount of ibuprofen is going to be the start dose plus the maintenance dose for 7 days. And that is 113 as a start dose plus 56.8 milligrams times, that should be 4 times a day, pardon me, it should be 4 times a day times 7 days. And that will give you the total amount of drug. So determining the source of the active ingredient is the next step. So we get the total amount of ibuprofen that we need, which is the start plus the maintenance dose for 7 days. Where is it going to come from? Is it the pure drug? Yes, in this case it is. So the source is going to be the pure drug, and based on the concentration, we are now going to determine the total volume. So the question tells you that we want every 2 mils to contain 40 milligrams. So therefore, if we're going to be needing 1,306.44 milligrams of ibuprofen in total, then that amount of ibuprofen will attract a certain amount of volume, or will be contained in a certain amount of volume, which would have been 65.3 mils. Because we are now going to be compounding for 65.3 mils of suspension, we have our drug, we have the volume, we now need to calculate, okay, how are we going to preserve the formulation? We're going to be using benzoic acid, which is available there. But we can't just jump and use 5% benzoic acid. We have to determine how much benzoic acid do we need to make our formulation preserved. We know that benzoic acid is used at a concentration of 0.1%, which means 0.1 grams in 100 mils. Therefore, how much would be in 65 mils, which is what you require to make, and that would be 0.0653. Now, there you can do one of two things. You can weigh the 0.0653 grams of benzoic acid, or you can get it from a stock solution. When we look in the question, we don't have the pure powder of benzoic acid, but what we do have is the benzoic acid 5% solution. So therefore, we're going to have to get the 0.0653 grams of benzoic acid from the stock. So available 5%, what does that mean? 5 grams is another 100 mils of the stock. So therefore, the 0.0653 grams of benzoic acid that I want to preserve my 65.3 mils of suspension is going to be contained in X, which is 1.3. All right. Next step we have to calculate the sweetener, which is one of the list of ingredients that they are requiring us to calculate. If we recall, the amount of sweetener, which is syrup that we normally use, is between a range of 10 to 30%. We decided to use 10%. That means 10 mils of the syrup will be in every 100 mils of suspension. Therefore, how many mils of syrup will be in 65.3 mils of the suspension? It's got 6.5 mils. Is there anything that we need to calculate? No, because purified water is a vehicle which we are going to add up to 65.3 mils. So we don't need to calculate for the purified water. And we remember that from enlarging and reducing formulas. So therefore, the new formula is going to be ibuprofen powder, 1,306.44 milligrams. Benzoic acid, 5% solution. We're going to use 1.3 mils of it. Syrup, we're going to be getting 6.5 mils of that syrup to sweeten our formulation, and then we're going to add purified water until we reach a final volume of 65.3 mils. And that would have been your suspension.